Account data matching vulnerability. On Solana, programs don't fetch accounts by themselves. Instead, users provide all the accounts the program will operate on. This means that your program must verify every account passed in that it's exactly the one that you expect. An account matching bug can happen when a program checks that an account exists but doesn't check if it's the right account. If an attacker can substitute a different account, one they control, the program may execute successfully but on the wrong state. Now, let's take this scenario. Now, we have an admin panel, a protocol with configurable withdrawal fees. So the admin creates a protocol config account storing fee rate and treasury address. Now, how can something go wrong with this? When an account or when a program is designed this way, where the config is a regular key pair, I mean, now the check here is has one, meaning just check that an admin field exists in this config account and also it matches the admin here. See what I mean? Here now, this is the protocol config, original protocol config, and then this is the attacker's config. Now, your update fee instruction says check if the admin passing as a signer is same with the admin stored in the config. So if it's this protocol config being accessing this instruction, it checks if this is equal to this and it passes. Now this is the attacker's config, and if you apply same rules here, checks if the admin, which is this here, is equal to what is in the config, which is what the has one constraint does, and it passes. So both the authorized admin and the attacker can access this instruction, making your program insecure and not safe for use. The better way to approach this is the use of PDAs. With PDAs, we can have one deterministic address that can only be accessed by the program. So with PDAs, you can derive an address with seeds and in conjunction with the has one constraint, confirming that the admin field is actually the signer. And like I said, the PDAs can only be controlled by the owning program, so the attacker cannot access it. Now on the exploit playground, here we have a protocol that takes 1% fee on every withdrawal. But with the vulnerable protocol, we intend to take 99% fee on every withdrawal. Already we have a config created, which is the original config, and then we have a fake config that takes 99% fee already created, and we have user balance of 9,000 plus tokens. Now, the user tries to withdraw 500 tokens, and you see the impact analysis saying the real program gives the user 495 tokens, but the fake program, which takes 99%, only gives the user 5 tokens. If we test it out here, testing out the fake config, wait to sign the transaction, we'll see that 495 tokens are added to the attacker's treasury. See here, as against the expected 1%. Now, if we try the secure program, we'll see that on 500 as well, when you try to withdraw, you see the fee is only 5 tokens and the user will receive 495 as expected. See it, the admin collects just 5 as shown. This as against the vulnerable program that takes 495. So this is a pure example of data matching vulnerability. So ensure that your config accounts are created using PDAs as shown here instead of regular key pair which anybody can create and match.